Evening. So today I am going to start matrices, and in matrices we will discuss first the most important part, and then slowly I will discuss other things also. And the main important part in matrices is uh, your algebra and that linear algebra, that is eigenvalues and eigenvectors. Okay, so let us first learn this, because the very small definitions, that what is matrix and all that, is not required for this syllabus. The main thing requirement is we will know all the properties of all type of matrices, and we will know this eigenvalues, eigenvectors, diagonalization of matrix, functional matrix. These advanced part we have to focus more. Okay, correct. Now one thing is that suppose you write a matrix, uh, in short it can be written as aij. Okay, so this is like any element of the matrix can be written like this, and if you put square brackets, this become a matrix. Okay, this becomes a matrix, and I write here m cross n like this. So m is number of rows and n is number of columns. Okay, so m is number of rows and n is number of columns. So suppose I write a matrix like this: a is equal to some a11, a12, a13, a14, and then a21, a22, a23, and a24, then a31, a32, a33, and a34, and a41, a42, a43, and a44. Correct? So this matrix is a 4 cross 4 matrix, because you can see there are 4 number of rows and 4 number of columns. So such a matrix is known as square matrix. Such a matrix is known as square matrix. Okay, and all type of matrices that are used in physics, most of the time you will see they are square matrices, because if you want to solve any equations, number of variables should be equal to number of equations. So in that sense also square matrix is very important. In quantum mechanics, whatever matrix you will use, they all will be most of the time square matrices. Okay, now जहां जहां पे नाम आता जाएगा, जरूरत पड़ती जाएगी, तो आई विल कीप ऑन एक्सप्लेनिंग. सो द फर्स्ट थिंग जस्ट यू नो is the square matrix. Baki, wherever the name will come, I will tell you about the properties. Okay, now let me explain. So let me explain what do you mean by eigenvalues and eigenvectors. So suppose A is any square matrix. A is any square matrix, and so suppose I apply this A on some another matrix X, and we get some lambda times X, and X is suppose a column matrix. Okay, so I will tell you in some time. So this is also a matrix, so for which you want to calculate eigenvalues. So if you apply to A on some matrix X, so this is kind of operator, and this is applied to this, so you get this again. That is the main thing. This thing is used in quantum mechanics also. Like there you write it like this: H of psi is equal to E of psi. Okay, so this is a Hamiltonian matrix there, and if you apply this, what you get is the same value of matrix here. Okay, so similarly you will get the same value here and a number. This is a number, and this number is known as eigenvalue. Eigenvalue. Okay, so this lambda will be known as eigenvalue. So I will explain this with an example. Eigenvalue means proper value. Proper value. So in this case, the value of E is energy eigenvalue, because this matrix is a Hamiltonian matrix which represents some energy. So this eigenvalue corresponding to that is known as energy eigenvalue, that you will read in quantum mechanics also. So now let me take a matrix. Let me give you an example how this is calculated. So this is clear?
Yes, sir. Yes, sir.
So let me give a very simple example to just make you understand how it works. So let us take a matrix, and that matrix is A is equal to 5, minus 5, 2, 2 and minus 2. Okay, so suppose this is the matrix, and if you write A some x is equal to lambda x, then what will happen? A x minus lambda x will become equal to 0, and if you take this common, so it will become A minus lambda I into x is equal to 0, because here you can't subtract A minus lambda, you have to multiply it with a matrix, because matrix में से matrix का ही subtraction होता है. Only matrix can be subtracted from the matrix because dimensions should be equal to subtract. So this I is known as unit matrix. This is unit matrix. This I is known as unit matrix. Okay. Now this I matrix, unit matrix means, suppose I write a 2 cross 2 matrix. So this 1 1 0 0, this is sorry, identity matrix. I for identity. Identity identity matrix, and I will use this I, and this matrix is 2 cross 2. So this is a square matrix having diagonal terms as 1 and off diagonal terms as 0. Okay, so now we want to calculate the, so you can see that this x cannot be 0, so A minus lambda I is equal to 0. So this equation is very very important, and this is known as characteristic equation. Characteristic equation. Okay, this equation is known as characteristic equation. Now let us see. A minus lambda I is equal to 0 means you will write it like this: A minus lambda I is equal to 0. So what will happen? Just this matrix will become, एक बार मैं सिर्फ लिख रहा हूं, बाद में डायरेक्ट लिखा करूंगा. So it will become A minus lambda I is equal to 0. So you can write it like this: minus 5 minus lambda minus 2 minus lambda 2 and 2. This determinant, actually the determinant value of this, so the determinant value of this, let us remove this. So this is equal to 0 is okay. Minus 5 minus lambda and minus 2 minus lambda, all other values will be same. Okay, so now let us solve this. So it will become minus 5 minus lambda minus 2 minus lambda minus 4 is equal to 0. Okay, and this will become, so this all will become positive because I can take, so it will become 10 plus 5 lambda plus 2 lambda plus lambda square minus 4 is equal to 0. So this equation will become lambda square plus 7 lambda plus 6 is equal to 0. So this equation is known as characteristic equation. This equation is known as characteristic equation. And there is very important property that I want to tell you right now, that if this equation can be written as this, f lambda is equal to 0, where f lambda is this function, then fa is also equal to 0. That means every matrix follows its own characteristic equation, and that is known as Cayley-Hamilton theorem. Okay, so you can write every matrix follows its own characteristic equation. Every matrix follows its own characteristic equation. So that means, let me tell you by putting this. So I can write a square plus 7a plus 6i is equal to 0. This equation will also be correct, and this has been asked once in NET exam, that if this is the matrix, which one of the following equations is correct. So if you have idea of these equations, you will immediately realize that you need to write the characteristic equation, and from the characteristic equation you will get this equation. Correct? Any doubt?
No, sir.
So now let us come to the point, and the point is, if you have noted it down, I will erase this one. So we have to solve this. So this is given by lambda plus 6 lambda plus 6 is equal to 0, and lambda plus 1 plus 6 lambda plus 1 is equal to 0, and lambda plus 1 lambda plus 6 is equal to 0, and lambda is equal to minus 1 minus 6. These values are known as eigenvalues. Okay, so physically they represent different things. Suppose in quantum mechanics they will represent energy, because the matrix for which you will calculate this will be Hamiltonian matrix. But in mechanical engineering it may represent something else, or somewhere other applications it will represent something else. Okay, so these are the eigenvalues. Lambda is equal to minus 1 and minus 6. One important property I want to tell you, that this this diagonal is known as principal diagonal. Principal diagonal. Okay. So the sum of eigenvalues is equal to sum of principal diagonal elements, which is also known as trace of A. So suppose these values are two values, lambda 1 and lambda 2. So you will write that sum of eigenvalues lambda 1 plus lambda 2, or if it is a 3 cross 3 matrix, lambda 1 plus lambda 2 plus lambda 3 will be equal to the trace of the matrix. Will be equal to the trace of the matrix. And there is also one important, so keep writing these as a property. Star bana ke alag se likhte raho, we will use all this. And there is also one important, so this is the first property, and the second property is that the product of eigenvalues lambda 1, lambda 2 or lambda 3, whatever, is equal to the determinant value of the matrix. So I can say the determinant value here of this matrix will be equal to 6, because the product is 6, and see, 10 minus 4 is equal to 6. So many things you can see from this matrix. So a square matrix, its characteristic equation, the matrix following its own characteristic equation, then the eigenvalues.
सर लास्ट प्रॉपर्टी एक बार और बता दीजिएगा सर.
ये वाली
तो लास्ट जो भी इसके ये से हुए.
Product of eigenvalues is equal to determinant of the matrix.
Okay.
What is this? Lambda 1 into lambda 2 into lambda 3 into जितने भी eigenvalues हैं, depending on what is the dimension of the matrix. So matrix, its characteristic equation, its eigenvalues, its properties, many things are clear. Now I also, so from one example let us understand everything, then we will do many other examples. Okay, that will be the method which I will follow. So please see this. This was the matrix A, and what type of matrix is this? This is a real matrix, all elements are real, yes? No iota is there. And if I take the transpose, A transpose, please see what will happen. Minus 5, 2, matlab rows are converted to columns, and 2 minus 2, it will not change. So A transpose will be equal to A. Such a matrix is known as symmetric matrix. Symmetric matrix. If A transpose is equal to minus A, skew symmetric matrix. Skew symmetric matrix. A transpose is equal to A is symmetric matrix. A transpose is equal to minus A means skew symmetric matrix. A dagger is equal to A, then it is known as Hermitian matrix. So what do you mean by dagger? Dagger means transpose as well as conjugate. And what is meaning of conjugate? Iota is just replaced by minus iota. This is meaning of conjugate. Correct? So A dagger is equal to A is Hermitian, And you understood what is dagger operation? And A dagger will be equal to minus A, then it is skew Hermitian. Skew Hermitian. Okay? See this carefully. These matrices will be used in your quantum mechanics also.
एक्सक्यूज मी सर
Hmm.
सर डैगर के अंदर ट्रांसपोज या कंजुगेट पहले या बाद में करें तो कोई फर्क नहीं पड़ेगा ना
कोई फर्क नहीं पड़ेगा.
सर
Now, if A for real matrix, if A transpose becomes equal to A inverse, this is inverse matrix, then the matrix is known as orthogonal. And if A dagger becomes equal to A inverse, the matrix is known as unitary. So all important matrices are here on this board. Please see this, and if there is, tell me, everything is clear?
Yes, sir.
So coming back to our matrix, this is a diagram. This is argand plane actually, and this is for eigenvalues. Eigenvalues. Okay. Now, if I draw a unit circle here, so this is real axis, this is imaginary, and this is a unit circle. So value here is 1, minus 1, here it is iota, and here it is minus iota. This is origin. So all eigenvalues, this is for eigenvalues, please see. All eigenvalues of symmetric and Hermitian matrix will lie on the real axis. Please see this. All eigenvalues of skew symmetric and skew Hermitian will lie on the imaginary axis, and eigenvalues of orthogonal and unitary matrix will lie somewhere on this circle, on this unit circle. So this is how all of the eigenvalue properties can be shown on a simple, on an argand plane, explaining everything. Please see this carefully. So our matrix was what type of matrix? This symmetric. So our eigenvalues कितनी आई थी?
-6 and -1
both are on the real x. Both. So anytime we will take some matrix from all these 6 type of matrices which are most important, and please see, in quantum mechanics, that's why your matrices are Hermitian, because you are calculating the energy eigenvalue, and eigenvalue should be a real number. Energy can't be imaginary, na? Okay, so that's why you have Hermitian matrices there. Correct?
Yes, sir.
So if you have Hermitian or skew or Hermitian or symmetric matrices, you will get real eigenvalues, and if you have skew symmetric or skew Hermitian matrices, you will have pure imaginary eigenvalues, because it is lying on this axis, but the value can be 0 also, because it is cutting here. Correct? So if you are talking about skew Hermitian matrix, eigenvalues will be either imaginary or pure zero. Either imaginary or pure zero. Correct? सबको समझ आ गई बात?
Yes,
Sir,
sir.
the last step.
Hmm?
Please repeat the last line. Sir, whose value lie is either on imaginary or zero.
Acha, you tell me. I have marked. Whose values will be imaginary? Tell me.
Skew Hermitian and skew symmetric matrix.
Then? So this line is also cutting this, na? This is imaginary line, but this
Okay,
is
sir.
also coming to zero. So values can lie on this whole axis, na? So they can be zero also.
Okay, sir.
So that's why अगर मैट्रिक्स स्क्यू हर्मिशियन है या स्क्यू सिमेट्रिक है तो वैल्यूज इमेजिनरी भी हो सकती हैं और जीरो भी हो सकती हैं. कैन दे बी कॉम्प्लेक्स आल्सो?
No,
No,
sir.
sir.
Tell me. Can the values be complex also for skew symmetric and skew Hermitian matrix? Can't
No.
answer.
Yes.
Yes.
Yes or no, bhai? Batao na.
Yes. No, sir.
Yes. How can be yes? If they are lying on the imaginary, so how they can be complex? They can be pure imaginary. Complex means there should be a real part also. So no value like this can appear for skew Hermitian. Only values like this will appear. Correct? Okay. Like 2i can come, but 2 plus 2i can't come for skew symmetric. Okay. So you'll have another class. So I will take this discussion. Just revise whatever I have taught. Then I will take this discussion forward. Okay. Thank you so much. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors. And I told you that you are going to get some question on this 100%. Some question will be asked on this for sure. Okay. And now I also took one example, if you remember. And what was that example? Let us write that example again. A is equal to 5 minus 5, 2 and 2 minus 2. So this will I will make you understand everything with this matrix, and then we will do other problems. Okay. So I told you that we can write a characteristic equation a minus lambda I x is equal to 0, where this characteristic equation, this characteristic equation, this will give some f lambda is equal to 0, its solutions lambda 1, lambda 2, like that. So if it is a 2 cross 2 matrix, you will get a quadratic equation. If it is a 3 cross 3 matrix, you will get a cubic equation. If it is a 4 cross 4 matrix, you will get power 4. Okay. So such an equation you will get, and these values are known as eigenvalues. I told you in last class. Okay. So we calculated actually the eigenvalues, and this capital X was eigenvector. This capital X was eigenvector. So now what we have to do is we have to calculate the eigenvectors corresponding to the eigenvalues. So please see this very carefully. So suppose A is a matrix lambda 1, lambda 2 are the eigenvalues, then this corresponding to a particular lambda, there will be an eigenvector. So capital X1, capital X2 will be the eigenvectors. This is the complete story that you must understand. So like in quantum mechanics also, this will become some H psi is equal to E psi, like that. And you will write H minus E psi is equal to 0, correct? So what values from here you will get will be known as energy eigenvalues, and corresponding to those energy eigenvalues you will get the vectors which will be known as eigenvectors. Okay, so the concept is purely mathematical, but the interpretations in quantum mechanics will be different. Atul sir will teach you all this. It will be coming there. Okay, so now please see. Now I have already calculated two values, eigenvalues, and what were they? So -1 and
-6.
-6. So now what I want to do is, please see this carefully. Corresponding to lambda 1, I will get a vector x1. Corresponding to lambda 1, I will get a vector x1, and corresponding to lambda 2, I will get a vector x2. So that I have to do. So how you will write? A minus lambda 1, correct? Lambda 1 I x1 is equal to 0. This will become the equation. Are you understanding this or not?
Yes, sir.
So just get this, a minus lambda 1. So suppose this is -1. So what you will get? -5 minus 1 will be -4, and -2 minus 1 will be -1, and you will get 2 and 2. So this will be the matrix, and the vector here, this vector x1, I am writing some x1 y1, or I can write x1 x2, whatever you want to write, x1 x2. So this is the column vector about which I was talking, correct? So it is a 2 cross 2 matrix. So here you must get some 2 cross something, because otherwise it can't be multiplied. So it is 2 cross 1. This everybody knows now. If it is a 2 cross 2 matrix, so you will get two in eigenvector you will get two bases. So those two bases are x1 and x2, in the form of which x1 will be written. So this will be a 2 cross 1 matrix, and what will you get? This is equal to 0 from this equation. This is the interpretation, correct? So it will become -4 x1, and you must know how to multiply the matrices. I hope you know.
x2
Plus 2x2 is equal to 0, and 2x1 minus x2 is equal to 0. Now these two equations are same. These two equations are not different, they are same. So that means we have only one equation. Is this okay?
yes
So
sir
we have only one equation, because these two equations are same. So if only one equation and two variables are there, how you will solve? So only method is, you have to write one variable as some some constant. So let us write x1 or x2, whatever you want to write. So 2x1 is equal to x2 is the solution, So how this vector will look like, this x1 vector, this will look like this. Here if you want to write x1, write x1 and the value of x2 will be 2x1, correct? Now if I assign x1 as some value, so suppose I assign this as k, so it will become 2k. So if I put the value of k is equal to 1, the vector will be 1 and 2. And if I write the normalized form of the vector, it will be 1 by 1 square plus 2 square under root 5, under root 5, 1 and is this okay? So this is the vector corresponding to eigenvalue lambda 1. Now the same procedure will be followed. So same procedure will be followed for writing the eigenvalues corresponding to, so this is x1 corresponding to this lambda is equal to -6, and please see what the matrix will become quickly. Now I can do directly. -5 -6 will become 1, -2 minus 6 will become 4, and then here 2 and 2, and the vector x2 here will is some x1 and x2 suppose, and this is equal to 0 0. So you will have x1 plus 2x2 is equal to 0 and 2x1 plus 4x2 is equal to 0. Again these two equations are same, correct? So what is the value? X1 is equal to minus 2x2. This is the value. So my x2 vector will be like this. If I write x2 as k, it will be minus 2k, correct? So if I take k is equal to 1, suppose, if I take, so what will be the vector x2? It will be 1 upon under root 5 and minus 2 and 1. So this is the vector corresponding to x2. So this is the complete question. You can understand everything from this regarding eigenvalue and eigenvector. Now let us take the dot product of these eigenvectors x1 dot x2. If I take the dot product, so what will happen? I can multiply. So this matrix is what? 2 cross 1, and this is also 2 cross 1. So I can only multiply if this becomes 1 cross 2. So I will take dash of this. So it will become 1 2, and this will become minus 2 1. So this is now 1 cross 2 and this is 2 cross 1. So final answer will be 1 cross 1. That is what is known as dot product. So it will become minus 2 plus 2 is equal to 0. So this I am inner product or dot product of vectors that I have done. So please see, this is symmetric matrix. So for symmetric matrix, you get the eigenvectors which are orthogonal. Dot product is 0 means they are orthogonal vectors. So inner product is 0 means vectors are orthogonal. And obviously they are linearly independent because if the dot product is 0, that means they are linearly independent also. Like I and j vector. I vector and j vector. These vectors are linearly independent. So if you take the dot product I dot j, what you get? You get 0. And what is meaning of linearly independent? It means that I cannot be written using some number and j cannot be written in the form of I. Okay. So this was a very good question to understand everything what we will do in eigenvalues and eigenvectors. A symmetric matrix was there. You got the eigenvalues which are real. I told you about the diagonal properties, trace also, and then the eigenvectors, then they are the inner product. Any question regarding this? Okay. So the next thing I want to consider is, so we will also writing the properties related to this. So I have already told you this, but please write down also. The eigenvalues of a square matrix A, the eigenvalues of a square matrix A are the roots of the characteristic equation, are the roots of characteristic equation capital A. Hence n cross n matrix has at least dash eigenvalue and at most numerically different eigenvalues. Fill in the blanks. So whenever something n cross n is asked, you just think about some 2 cross 2, what we have done. So if there is 2 cross 2 matrix, what will be, how many least numerically different eigenvalues you may have? No, one. One. So suppose you have a 2 cross 2 matrix and you got eigenvalues as lambda 1, lambda 2. So there is a possibility that you get 2 2 as an eigenvalue, na? Or 3 3 as an eigenvalue. So here you will fill 1. ये gate का question हो सकता है. And what about here? N. Because there is a chance that you get -1, -6 like you got. So these are two distinct eigenvalues. Two distinct eigenvalues. Please see this, understand this properly. Okay. And what about the eigenvalues? Eigenvectors? eigenvectors, we may have n linearly independent eigenvectors, or suppose the values are same, so we may have less also. Please understand this. So like suppose there is a 3 cross 3 matrix and you got values as 1 1 1, suppose eigenvalues. So corresponding eigenvector may be three linearly independent eigenvector, but there is a possibility that you are able to write only two different, correct? So that's why there is a chance of getting less linearly independent eigenvectors also. This point is okay?
Okay, sir.
Like in our case, how many linearly independent eigenvector we got for 2 cross 2 matrix?
2, sir.
2.
Two.
So it was this case. But there was a possibility कि तुम दोबारा लिखते and you have got the same eigenvector. You can't change it. So then what was the answer? 1. So see, this is previous year question. Please see this carefully. When this comes as a language and things are not clear, you will not be able to write. So there are n linearly independent eigenvectors. There is a possibility of getting n linearly independent eigenvectors, but there is also a chance that you get less than that also. Okay?
Yes, sir.
And a simple thing that you have a matrix A and you get eigenvalues, suppose lambda 1 lambda 2, and suppose those eigenvalues are 1 1. So these are known as degenerate values. Degenerate eigen value. Okay, this is in physics also the same word is used, degeneracy. So that means you got the same energy eigenvalue. So this is known as degeneracy. That means the state is different, but you got the same energy eigenvalue. So here in mathematics we will just call that this is doubly degenerate. What we call this is doubly degenerate, because two values are same, so we will call this as doubly degenerate. Okay, this point is okay. So now let us take a matrix capital A is equal to -2 2 -3 2 1 6 -1 -2 and 0. What type of matrix is this? Anybody can tell?
Square.
Square is there, of course.
Antisymmetric.
3 into 3 square matrix.
Antisymmetry matrix.
Antisymmetric. It is antisymmetric.
No, sir.
For
Symmetric.
for skew symmetric matrix, all the diagonal elements are always 0. Let us see how is that possible. Please see this. Suppose there is a matrix A, and what happens for skew symmetric matrix? A dash becomes A. Yes, correct now. So if there is a matrix A and suppose its elements are written as Aij, so what will be A dash? Rows and columns are exchanged, so it will become Aji. Correct? So A dash will become minus of Aji. And for diagonal elements, I is equal to j. So if this is the case, a is equal to a dash, what will happen? I will become minus I, correct? So 2
Yes, sir.
times I will become 0. So that means all diagonal elements will become 0. This is a very important property of skew symmetric matrix. So if all diagonal elements are 0, the matrix may be, it is not confirmed, it may be a diagonal matrix. But if it is a skew symmetric matrix, then for sure all diagonal elements will be equal to 0. Here, this was something else. You have noted it down, everybody? This is another important property I told you.
Sir,
Hmm.
sir, for skew symmetric matrix, A dash is equal to minus A.
A dash is equal to minus. So here I have taken, you see, minus. तभी तो मैंने ये लिखा है ना minus. Okay? Let me write it. So tell me, what type of matrix is this? Anybody can tell? Just a square matrix, no, it's not a symmetric or not a जरूरी नहीं है ना कि symmetric हो या skew symmetric हो. Okay? So please write A minus lambda I x is equal to 0 and characteristic equation f lambda is equal to 0. Write quickly, everybody, and tell me. So you will have to write it like this: minus 2 minus lambda, 1 minus lambda, 0 minus lambda, 2 minus 3, 6, 2 minus 1 minus 2 is equal to 0. And then open this. So it will become minus 2 minus lambda and this minus this. So 1 minus lambda into minus lambda plus 12. So this will be plus minus plus. So minus 2 times minus 2 lambda plus 6 minus 3 times minus 4 and plus minus 4 plus 1 minus lambda. This is equal to 0, correct? Everybody knows now how to open determinant?
Yes, sir.
So what equation will be formed? F lambda is equal to 0. Anybody can tell? Calculate किया किसी ने?
Cubic.
Cubic what equation? So it will be lambda cube plus lambda square plus 21 lambda minus 21 lambda minus 45 is equal to 0. This is the equation, characteristic equation. जल्दी से करके देखो. This is the characteristic equation that is formed. And if I use the Cayley-Hamilton theorem, just to tell you, it is not required in this, but suppose I use that, so what equation I will get? A cube plus A square minus 21A minus 45I is equal to 0, because every matrix follows its own characteristic equation. Every matrix follows its own characteristic equation, so you will get this. And please see, I am telling you something else. So you can also calculate inverse using this. For example, you can write 45I is equal to A cube plus A square minus 21A. This you can write, and now multiply A inverse. So you will get 45 A inverse is equal to A square plus A minus 21I. So what is the value of A inverse? A square plus A minus 21I by 45. Please see this. This is very, very important.
In the f of h after 0, put the first row, the 2 minus 2 plus lambda instead of, sorry, minus 2 minus lambda, but you put plus sign, sir. That I couldn't understand, sir.
You don't know how to open determinant? Determinant. Like suppose you have this 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose this is some determinant. So can you open this determinant? So it is opened like this, plus, minus, plus. So you take 1 and then
Okay, sir.
determinant 5, 5, 9, 45 minus 6, 8. 48. Then you take negative sign of this. So minus 2 and like this. 36 minus 40.
Yes,
This
sir,
you know.
yes, sir.
This I am
That
telling.
different I am saying.
So the same thing I have done. Nothing else. Everybody got same values?
Yes, sir.
This everybody got same or not?
Yes, sir.
Yes, sir.
And one question here, A inverse. You will have no idea if you don't know this Cayley-Hamilton and how to write it. Many times it has been asked. So if you are done with this, okay, that will be written. Don't worry. That inverse part will be written. Now we have to solve this equation, and please see, many times in exam you have got this cubic equation. So how to solve this cubic equation? See this last digit. It is 45. So there is a possibility of 3, 5, which is, which can divide this number. There is a possibility of getting that as a factor. So we will check that because there is no other method. So suppose I check first of all 5. 5 is it one of the roots. So check 125 plus 25 minus 105 minus 45. Please check. This is 0 or not?
0, sir.
0. So
Zero, sir.
that means 5 is one of the roots. So we only need one root, then I can solve. Please see. So 5 is one of the roots. This is plus 1 mathematics, you understand. So 5 is one of the roots, so write this 3 times. Okay. So I will write this same equation here because I know this is one of the roots. So I have written lambda minus 5, lambda minus 5, lambda minus 5. So here it will come lambda square. It will become lambda cube minus 5 lambda square, correct? So lambda cube is okay, it is here. But here comes minus 5 lambda square, and here we have lambda square. So what I will write? Plus 6 lambda. So that 6 lambda square will make it lambda square. Then you have got minus 30 lambda, but here it is minus 21. So I have to subtract plus 7 so that it becomes minus 21, and last one automatically
minus 7.
just do it. So this is lambda cube and minus 5 lambda square. So plus 6 lambda, lambda minus 5. This is okay. So you got 30. So 30 and 21, 9, na? 9. And this is equal to 0. So you will get lambda square plus 6 lambda plus 9 into lambda minus 5 is equal to 0. And please do this quickly. So you will get lambda plus 3 square lambda minus 5 is equal to 0. So what are eigenvalues? 5 minus 3 minus 3. Many times this is a previous year question in GATE as well as NET. And you can see clearly the degeneracy, doubly degenerate. If you want to write one more step here, you can write it like this: lambda plus 3, lambda plus 3, lambda minus 5 is equal to 0. So we got 3 eigenvalues, and you can cross check also using this property that the trace of A is how much? Minus 1. Add all these 3, you will get minus 1. And can you tell quickly what will be the determinant value of A?
45.
It will be 45. Multiplication of all the 3. Fine. So just see this. Can I erase this? Everybody noted it down?
Yes, sir.
सबने नोट कर लिया है ना? Everybody has noted it down? Very good. So let us now quickly calculate the eigenvectors, and that will complete our cycle. Let us go for eigenvectors quickly. So the first one I will calculate for lambda is equal to 5 because that is different. So I will write minus 2 minus 5 minus 7, 1 minus 5 minus 4, 0 minus 5 minus 5, and then 2 minus 3, 6, 2, minus 1, minus 2, this into, now this time suppose some x1 eigenvector I want to write, so I will have to write it like x1, x2, x3, and this is equal to 0, 0, 0. Correct? So quickly write the equations. So minus 7 x1 plus 2x2 minus 3x3 is equal to 0, and 2x1 minus 4x2 plus 6x3 is equal to 0, and minus x1 minus 2x2 minus 5x3 is equal to 0. And if you want, before going here, you can make here elementary row transformation to just reduce this to very simple values. So what you will get here, the equations, you see, you can divide it by 2, so it will become 2 here, 2 here, and 3 here. Or you can solve it here using elementary row transformation. That also I can show you. Five minus 3 minus 3, just to remember. So please see, we can solve this by just making some elementary row transformations here. So like the first transformation maybe you just reduce this, like माइनस से मल्टीप्लाई कर दिया, देन इसको 2 से डिवाइड कर दिया, देन सब्सट्रैक्ट कर दिया. We can do all that, but let us solve it quickly. What we are going to get? How to solve this? So if you want to solve this, reduce same quantities. Like इसमें और इसमें से भी x2 हटा लो और इसमें और इसमें से भी x2 हटा लो ना. That is the method. So suppose I want to take out x2 from this, so what I will do? Add this. What you will get? Minus 6x1, and this is same na. So the minus 6x1 is equal to 0. Please see. Here there is some mistake. Minus 2, 2, minus 3, 2, 1. This was minus 6. 2, 1, minus 6. And minus 1, minus 2, 0. So here what it will become? If I subtract वो नो नो प्लीज सी, वो जो मैंने क्वेश्चन लिखी ना वो आप देख लेना, जहाँ पे माइनस प्लस होगा. मैंने वो फाइनल वाला,
हाँ सर वो वाला
हाँ
नहीं
सर
आया, मैंने वो वाला
वो
गलत
वाला
आया,
माइनस
लेकिन
कोई बात नहीं, आप ये चेंज करके वो कर लेना, ठीक है ना.
हम्म।
वो तो जस्ट मैंने आपको मेथड बता दिया था, ये नेगेटिव साइन यहाँ पे था. So otherwise that will become a different question. ठीक है ना?
Yes,
That will
sir,
be,
yeah,
हाँ,
yeah.
that will become a different question. You can solve that also. So what will be here? It will be minus 6. And when you multiply here, what you will get? 2 minus 2 and here minus 3, na? So this. So 3 questions will be minus 7, 2 minus 3, 2 minus 4 minus 6 and minus 1 minus 2 minus 5. Now it is okay. So here we will get this. So what if we add them? What I will get? Minus 6x1 minus 6x3. is equal to 0. Correct? And what about here? Again, I don't want x2. So I will have to subtract, na? So here I will get 2x1. This will be gone. And this will be plus 2x3 is equal to 0. So the first equation will be what? x1 plus x3 is equal to 0. x1 will be equal to minus x3. That is the equation. x1 will be equal to minus x3. Correct? So put that in any equation you like. Suppose इसमें put कर दूं. So this will be x1 is minus x3. So what it will become? x3 and minus 5. So it will become minus 2x2. Tell me, bhai. Minus 4x3 is equal to 0. Please see. So what will be the value of x2? x2 plus 2x3 is equal to 0. So x2 will become minus 2x3. Correct? So x1 is minus x3 and x2 is minus 2x3. So just write it like this. How to write the vector? So suppose I take x3 is equal to 1. x3 is 1. So what x1 will become?
-1.
-1. And what x2 will become? -2. And what will be the normalization? Correct? So this is the eigenvector corresponding to that. So I hope everybody understood. Now please see. Now homework is, we will discuss tomorrow that. Homework is, two eigenvalues are there na, -3 and -3. And we have to find other two vectors. This was x1 vector that we have found. So you try. So this here you will also learn how to calculate a different eigenvector using same eigenvalue. Because अगर आप quantum mechanics से term में सोचो तो ये energy है. This is energy and these are states, wave functions. So same energy may have two different states, na? That is what degeneracy is. So we may be able to calculate two linearly independent eigenvectors. Correct?
सर वो लीनियरली इंडिपेंडेंट की डेफिनेशन पूछ रही हूँ.
So see अभी यहाँ पे पहले सिंपल ये समझ लो कि एक वेक्टर x2 है. अब सपोज x2 becomes 3 times x3. So are they independent?
No.
No, they are not independent. But I and j, I gave you इतना बढ़िया एग्जाम्पल है समझने के लिए. Suppose two vectors are there, I and j. Can you write I is equal to some constant times j?
No.
So these are independent vectors. They can't be written in the form of one another. And if I write mathematically, even you will not understand. If you don't understand this thing, you will not understand that definition. Let me tell you quickly, and then we will. I wanted to discuss that separately, but that's why I just gave you. So suppose you have vectors a1 x1 plus a2 x2 plus a3 x3, okay, like that is equal to 0. So suppose this is equal to 0 only when all these coefficients go to 0. Correct? Then the vectors are linearly independent, otherwise dependent. Because I plus j, a1, a2, this is equal to 0 only when a1 and a2 becomes 0. So that's why I and j are linearly independent vectors, correct? And here meaning of vector will be some column vector, not only that Cartesian vector having 3 elements. It may have n elements also. ये बात समझ आई भाई जिन्होंने पूछा था?
Yes, sir. Yes, sir.
अब अगर 2 ले लो तो ज्यादा अच्छा है समझने के लिए. a1 x1 plus a2 x2 is equal to 0. Okay? So suppose x1 becomes minus a2 by a1 x2 and this is not equal to 0. So that means x2 can be written in the form of x1.
Yes.
So they are
Dependent.
linearly dependent. Okay?
Okay. Thank you, sir.
चलो let us stop here and I'll take this. So ये समझ लो 2-3 क्लास में 3-4 क्लास में 100% you will get questions in your exam, in every exam. Eigenvalue, eigenvector, properties of matrix, functional matrix, diagonalization, linearly transformation, all we will discuss here in very concentrate form. So don't miss the classes. That will be very, very helpful for you. Okay, thank you so much.
Sir, reference book for
Thank you, sir.
Reference book is Erskine and Krzyk. Okay,
Thank you, sir.
thank you.